Assalamualaikum and hello everyone. Welcome to the video where we'll be discussing the solution to revision question. This video we look for chapter 1 reaction kinetic. Okay, so let's look for question number 1. So here it mentioned the reaction between gases ammonia and oxygen is this equation. Then write the differential rate equation for the reaction. Okay, so for the differential rate equation, it must be over dt lah. You have to mention the rate is equal to the reactant, which is equal to the product as well. Okay, but then for the change itself, rate ni kan is over time kan, so that's why the over dt lah. D ni it means that the change, change in the concentration over change in time. Okay, so here we have our reactant. For the reactant, it must be a negative sign. Okay, so why negative sign? The negative sign ni is to show that the concentration is decreasing. While the positive sign ni for the product ni to show that the concentration is increasing lah. So that's why we put the positive negative sign. But then again, remember, because based on this equation, we have our coefficient in front, right? 4, 3, 2, 6 here. So we have to include it in our equation. 1 over 4, 1 over 3, 1 over 2, and 1 over 6 here. Okay? So this is the equation. It's quite straightforward. Next question, if the rate of formation of water is 0.81 molar per second, determine the rate of disappearance of ammonia. Okay, so from the information given, okay, rate of formation, formation is positive lah. Senang nak tengok from our equation itself, it's a product, so it must be a positive. Next, they ask you to the rate of disappearance of ammonia. Ammonia is our NH3 here. Disappearance, so it means that it will be a negative sign lah. Okay, so here is the information from the question. Okay, here is our unknown. Sebab tu Miss includekan positive and negative. Okay, but then how to answer this question? Okay, so to answer this question, okay, we are considering ourselves with H2O and NH3. So for the comparison, we're going to take the NH3 ni is equal to 1 over 6 dH2O over dt. Okay, so first we have to compare based on our equation lah. Okay, remember, but then from the question, we only want the negative sign as well as the dNH3 dt ni lah. 1 over 4 ni kita tak nak. Okay, and then for the 1 over 6 dH2O dt ni, we're just gonna let it be. Okay, sebab yang ni kita punya unknown kan. Okay, so what happened is that we want it to be this one. So 1 over 4 ni, we're gonna change it, move it to the other side. So it will be multiplied by 4. Okay, so here 1 over 6 H2O. 1 over 6 includes sahaja. The concentration H2O ni, the rate of formation is actually 0.81 times dengan 4 because we have moved it the other side here. So you will get the answer to be 0.54 molar per second. Okay, so for this question, first what we're going to do is actually write down the information. For the comparison itself, based upon your rate equation, differential rate equation. Okay, from there, then you can find your unknown where you have to change around lah. Yang ni kena ubah sikit, okay? So that's for question number 1A. Question 1B, here. Sketch and label a curve showing Maxwell-Boltzmann distribution at temperature of 300 and 500 Kelvin. And then give two factors which can increase the rate of reaction. Explain. Okay, so first we're going to do is the Maxwell-Boltzmann distribution, where the y-axis is number of molecule and x-axis is the kinetic energy. Okay, for these two different distribution, it's actually the number of molecule, the area under the graph is actually the number of molecule lah, which is the same. Okay, so for lower temperature, you're going to draw it to be higher and more to the left lah. Macam ni pun boleh juga. And when for the temperature is higher than that, the higher the temperature, kamu akan buat dia more to in the middle there. Dia lagi rendah lagi. Okay. Okay, so and then make sure label lah the temperature itself. Okay, for this one, it's actually the extra part. It's actually here. Okay, so at one point ni, you're going to label it as activation energy. And then here, I already shaded the area as well. Here is to show that, okay, the shaded area is to show this is the number molecule which have the kinetic energy is higher than the activation energy. So even though the question does not ask, I'm just going to do it lah. just to be safe. Okay, later I'm going to explain it during this one. Okay, so next is give two factors which can increase the rate of reaction and explain. Okay, so the rate of reaction is actually, it is important for the explanation based upon the number of effective collision. Okay, this is actually based on your notes juga dekat 1.3. Okay, so we have learned, okay, for the rate is actually directly proportional to effective collision and inversely proportional to time. Effective collision ni yang change the reactant will be product lah. Okay, so there are two requirements for effective collision. One must be the collision must be in correct orientation, as well as the kinetic energy of the molecule, Ke, is higher than activation energy. Activation energy tu is the minimum energy required for the molecules to react. Okay, so kiranya dekat sini kita punya Maxwell-Boltzmann distribution ni, yang lebih daripada activation energy ni is the one that will undergo effective collision. Effective collision ni maksudnya it will change the reactant to the product. Okay. So for the factors actually, factors kalau kamu nak nota ada 5 lah. Okay, first is concentration, ada pressure, ada juga surface area, here have catalyst and we have temperature. So concentration ni boleh explain, the explanation sama dengan pressure dengan surface area, cuma awal ni je lain sikit. Okay, so when you mention about the factors, first you have to write lah. So when the concentration or when the factor increase, what happened? So when concentration increase, the number of particle per unit volume increase. Okay, for this one, as well as the pressure dengan surface area, you have to mention juga the number of collision increase and the effective collision pun increase. Mention paling penting effective collision ni lah, sebab we know that is directly proportional to rate. Once you have mentioned about the effective collision, then you can write down the rate of reaction pun increase. Okay, so it is important for your solution mesti ada effective collision ni. Okay, next is your catalyst. Okay, so catalyst pula ada lain explanation dia. When catalyst is added, alternative pathway with a lower activation energy is produced. Hence, nanti bila dah lower activation energy, maka the number of molecule that have higher energy than kinetic energy will increase. So, bila the energy is higher than, have higher energy than kinetic energy, this one is have higher energy than activation energy akan increase. Hence, the number of effective collision increase. Okay, remember, sebab kita nak the kinetic energy is higher than EA, hence it is effective collision. When effective collision increase, rate of reaction pun increase. Okay. If you mention about temperature, so for the temperature, you have to mention temperature increase, the kinetic energy of the molecule pun increase. Okay, and then when kinetic energy increase pun sama juga. The number of molecule that have higher energy than activation energy increase. And requirement this one. Okay, and then barulah mention effective collision increase and the rate of reaction increase. Okay, so for the catalyst and temperature, you have to mention yang pasal ni lah. Ke is higher than EA. This one. Okay, tapi kalau concentration, you have to mention like this explanation, and number of collision and effective collision increase. So that is the explanation. Sebab explain kan, so kena banyak points sikit lah. Okay, so that's for question number 1. Okay, question number 2. So table 1 refers to the following reaction. Okay, determine the order of reaction and the rate constant for the reaction itself. Okay, so order of reaction macam mana? Okay, so before we determine the order of reaction, we have to write down the rate law. This is what we call as rate law. Rate law ni different dengan differential rate. Kalau differential rate, okay, differential rate yang ada dt ni lah. This is yang kita panggil rate ni. Differential rate. Kalau rate law is the one yang rate is equal to rate constant, concentration of our reactant. In this case, reactant kita A and B only. To the power of X dengan Y ni is actually our unknown. Jangan tulis nombor. It is our unknown. Okay, so from there, kita kena carilah what is X and Y. Okay, to find the order of reaction with respect to A, kamu kena cari, we're gonna use the same concentration. Use the same concentration of B. Okay, supaya yang ini kita boleh cancel out. Ini kita boleh cancel out. Mana lagi? Ni kita cancel out. K pun kita boleh cancel out kan. Okay, so if you use 1/2, you will still get the same answer. Okay. While for the B itself, yang B ni pun, for the B, to find the order of reaction with respect to B, we're gonna use the same concentration of A. Dalam case ni, because we're gonna cancel out A, nanti we will get the value itself lah. Okay, so if you want to use 1/3, still you will get the same answer. Okay, so you will get the order of reaction with respect to A is 1, the order of reaction with respect to B is 2. So then you have to write down lah. Rate is equal to Ka, concentration of A times concentration of B to the power of 2. Okay, to determine the rate constant, we're going to substitute the value into this formula. Okay, so I'm just going to use from experiment 1 lah. Okay, so when I include the value, I will get the value to be 125. How about the unit itself? Okay, kalau tak pasti, you're just gonna write down kat tepi ni untuk determine the unit. What I did here is actually I write down again the rate law. Okay, I know that based upon the information given, rate ni adalah molar per minute. This is based on here. Ni adalah m per minute lah. If you want to use mole dm to the power of -3 per minute pun boleh juga. Okay, and then from here, K, A to the power of 1. So maknanya this is concentration unit the M. Okay, B to the power of 2, maksudnya M squared. Okay, and then to determine the K, here is actually M to the power of 3. Lepas tu bawa ke sini, so it will be M per minute divided by M to the power of 3. So this one, -2. Ni dah tak ada lah. So that is how we get the unit for this rate constant. Okay, so that is for the calculation. Next question. Question B. Okay, B, describe the factor that affect the rate constant of a chemical reaction. So the rate constant is actually our K. Okay, tadi kita mention pasal rate of reaction ni lain. Rate of reaction, this is rate of reaction lah. This is rate reaction. Kalau rate constant is actually K, where K ni, where K ni is actually the for the formula we have learned based on our Arrhenius equation. Okay, so for our Arrhenius equation ni, we can say that okay, A ni is Arrhenius constant, E ni is our exponent lah. Okay, R ni is a gas constant. So it means that based upon this equation, the factors that affect K is actually activation energy dengan temperature. Okay, so this is actually based upon your notes. I can't remember which page. Tapi sebenarnya nak explain dia simple sahaja. When temperature increase, the rate constant increase. Okay, ni increase lah. Okay, if based upon your notes, sekejap, let's tengok. Okay, so on your notes is actually on page 22. Okay, this one is actually example where I have included the value. So contohnya bila T ni increase, we can see that K dia increase. So itulah explanation dia. For the EA ni pula, when EA increase, what happen is that the K decrease. This is actually where I included the value. So it will be easier for you to inilah. When temperature increase, the rate constant increase. While if the activation energy increase, the rate constant decrease. Okay, so that's for the explanation for question 2. Okay, next question. So, question number 3 here, okay, it mentioned that on January 1st this year, the amount of concentration of insecticide has been washed, assuming the average lake temperature is 25 degrees Celsius, and the rate constant for the insecticide is 1.45 per year. What would be the concentration of the insecticide on January 1st next year, and determine the half-life? So, this one are the two questions. Okay, so bila dia bagi dekat sini, we have our concentration, we have our temperature. This is actually rate constant. We have our K. Okay, so what will be the concentration and what would be the half-life? So bila kita nampak macam ni, especially half-life, we have to know lah. Kita kena tengok yang zero order, first order and second order. Okay, on your notes it will be on page 7 ni lah. Yang ini Yang zero order, first order, second order. So which one? Because we have many formula kan. Maksud dia for each order ni ada 2 of the formula. So which one we're going to use? Kita tengok balik pada soalan tu. Okay, for the question, dia dah bagi hint apa-apa tak? It does not mention explicit lah, zero ke, first ke, second. But then because it mentioned the rate constant here is 1.45 per year. So tengok ini unit dia per year. So for the rate constant, if it's a zero order, it will be molar per time. This one is per year. Okay, kalau first order, unit dia adalah per time. Sini unit dia per year. So this reaction is a first order reaction. Okay, so first order reaction, this is the formula that we're going to use lah. Okay, ln A0 minus ln AT equal to KT. Okay, so macam mana nak cari concentration of insecticide on January next year? Okay, so maknanya from January this year to January next year. Maknanya our time tu will be 1 year. Okay, so kenapa kita guna 1 year bukan guna 12 months? Kan? Because the unit of K itself is year lah. So sebab tu T ni pun kita guna year. Okay, so K kita dah ada. Okay, yang ini jadi apa? This one is actually concentration on January this year kan? Nak tanya January next year. So this is actually yang January 1st this year and this concentration is our initial. Okay, yang concentration after 1 year will be our unknown. So here is the solution. So do step by step. Tapi jangan lupa, there's one more question. Determine the half-life. Half-life is half-life ln 2 divided by K. So you will get 0.47 per year. Okay, so that's for question 3A. Question 3B. Okay, the activation energy for the reaction between hydrogen gas and iodine gas is 165 kJ per mole. Sketch and label energy profile diagram for this reaction. Determine the activation energy reverse. Okay, so before for the energy profile diagram, we have learned about exothermic dengan endothermic. First thing first, we have to determine from this equation is it exo or endothermic. From this case, since it is a negative sign, so it is exothermic reaction. So from exothermic reaction, then you know lah, you can draw the energy profile diagram for exothermic, because exo dengan endothermic is very different. Okay, so for the graph itself ataupun the diagram tu, okay, you have to label the potential energy, the y-axis, reaction progress is x-axis. Time pun boleh jugalah. Okay, so what you're gonna have, you need to have your reactant, specific reactant kita H2 dengan I2, our product is HI. Okay, and then we have to mention juga sebab dia buat bukit kan, from here to here bukit dia. Here is our transition state, so labelkanlah. Okay, besides that, we have to label activation energy forward, activation energy reverse, and delta H. Activation energy forward is actually from reactant to transition state. This one. Next is activation energy reverse, product to transition state. Reverse product to transition state. And delta H is reactant to product. This is reactant, this is product. Okay, so kenapa macam ni? Sebab kalau sebenarnya the order of the reaction tu sebenarnya reactant pergi transition state pergi product. So EA forward, reactant to transition state. Reverse ni sini ke sini pula. Okay, so this is actually the energy profile diagram. Okay, next is to sketch and label energy profile diagram ni dan determine the activation energy reverse. Okay, here it mention delta H. Okay, kat sini dia ada bagi juga activation energy. Activation energy ni forward ke reverse? Okay, since the question asks for reverse, so it means that this one is forward lah. Okay, so which formula we're going to use? We're going to use delta H is equal to EA forward minus EA reverse. This one is actually on your notes dekat sini. This one, EA forward minus EA reverse. Okay, so kat sini lah tengok exothermic and endothermic is different lah, slightly different. Okay, different dia tu, kalau exothermic, the reactant is higher than product. Kalau endothermic, reactant is lower than product. Dia bukit dia tu jadi lain sikit. Okay, so when we substitute the value, includekan sahaja negative, so we get EA reverse. Okay, so that's for question 3B. The last question for this chapter 1. Here, a compound wine with initial concentration of 4 molar undergoes decomposition to form Z. Okay, the rate constant at temperature 298 is this. And the activation energy is 70.8 kJ per mole. Determine the half-life and calculate the rate constant of the reaction at 350 K. Given R, okay, this is your gas constant. Okay, so first kita tengok half-life. Again, half-life it must depends on kena tahulah dia ada 0, 1 ataupun first ataupun second order. Since here it mentioned that K is per molar per second, then we know that it is a second order reaction. So the formula ni kita includekan sahaja. Okay, so next what we're gonna do, we have find out our half-life. Next is calculate the rate constant of the reaction at 350 K. So when we're talking about dia nak K, this is K, this is temperature. So it involve our Arrhenius constant lah, where we have our K, we have our temperature juga. Okay, so if we use this formula straight away, K ni unknown, kan? EA dah bagi, R dah ada, T pun dah ada. But then this E is Arrhenius constant. Even though kita ada Arrhenius constant, kita tak belajar yang ni. Value dia bukan satu. It has its own value. Okay, tapi kita tak ada value A. So we can't use this one. So what we're going to do is actually we're going to use this formula. Ln K1 divided by K2 equal to T2 over minus over T1. Okay, so it means that bila K when T1 ni, what is T1? When T is equal to certain temperature, that will be the K lah. Kalau temperature di T2, that will be our K2 juga. Okay, so mana satu K1, mana satu T1, okay, up to you. Contohnya dekat sini, because at 298K, we get this K kan? Kelvin, we get this value. So this one I denote as T1 and my K1. Okay, and then, dia tanya, what is the K when temperature is 350 Kelvin? So this is my K2, this is my T2. Okay, so this one, okay, remember when we use this formula, R is our constant. EA is activation energy, must be in joule per mole. So we have to change it into exponent 3, kilo kepada biasa, kilojoule to joule times 10 exponent 3. Okay, and then the temperature must be in Kelvin. K ni dua-dua ni must be the same unit lah. So when I substitute this value, I will get 2.06 per molar per second. Okay, so that's it.